going. So again, good morning, everybody. Let's do this. Get out your notebooks. Today we are focusing on graphing and what the A value is. So some of these will look familiar. I did change them up a little bit from the slide from yesterday, but we're going to graph all 5 of these, taking the information that we already know. Now, there's 2 ways that I'm going to show you. The first way, you're not going to see me do this very often, but I am going to show you it's a viable option. The first thing that I'm going to do on number 1 is find the vertex. So the very first thing I want to do is find the vertex. So what is my vertex in this graph right here? First of all, let's go through one thing at a time. What is my A value? Does anybody know what the A value is?
-1.
On number 1?
Yeah.
No, your A value is what's the coefficient for here, multiplied right here. And it's not a 0. What is this value right here?
A 1.
Yeah, if you don't see it, it's just 1. So these are things that we have to know. We have to be able to pick out. So your A value is 1. Your H value or your X value for the vertex is going to be what? Is it +3 or -3?
+3.
+3. It's always the opposite. Always, always, always the opposite of what's happening to X inside the quadratic. And your K value is -1. Again, a real simple explanation. This would have been moved or transformed right 3 down 1. Why is it right 3? Because what this is really saying is what value of X makes the quantity equal 0. And it's always going to be the opposite of this. So that's why it's 3 -1. So find the vertex. Now you are not going to see me do this very often, but this is how I'm going to explain it. At the point 1, 2, 3, -1, that's my vertex. Now let's see what else we know. So by the way, do I know if this opens up or opens down? Do I know that at all?
Yes.
How?
It opens up because there's no negative coefficient for the X.
Right, because A is positive. Because A is positive, that has to open up. It has to, right? So I know it's going to look something like this. But again, as a math teacher, we don't really say it's going to look something like this. We pay attention to detail, right? So I know that it has to open up. And it has to make a parabola, which is that U-shaped figure, right? So from the vertex, we have a couple different things we can do. You can always make a table. And I need 5 points. Every time you graph, I need 5 points. And the vertex is always, always, always going to go in the middle. Now, we're not going to really talk about this until Thursday, but we have what is called an axis of symmetry. Now, this is actually really important, this axis of symmetry. So I'm going to talk about the idea. We're going to talk about this more on Thursday. So what this means is the axis of symmetry kind of acts like a mirror. So if I had a Y value that was right here, well, there's 2 steps away, so it'd have to be the same Y value 2 steps away. If I had a Y value right here that's 3 steps away, then again, 1, 1, 2, 3, 1, 2, 3. That's the concept of why the axis of symmetry is so important. Now, what that means, and make sure you guys listen closely to this. This is really the heart of the lesson right off the bat. From the vertex, if I take an equidistant step left and right, if I take an equidistant step, that doesn't mean they both have to be 1, but that's a good place to start. So if I take an equidistant step up and down, what's 1 step bigger than 3? I would be at where? I'll go ahead and answer that one. I'll be at 4. And if I go up 1, then I have to go down 1. So I'd be at where? Right here.
2.
Good. Now, just for good measure, again, the step from the vertex, and this is really important, the step from the vertex has to be equidistant out here. I didn't say it had to be 1 all the time or 2 all the time, but from here to here and here have to be the same. So what if, and I'm not saying I have to do this at all, I could just keep taking steps of 1. What if I went down to 0? If I went down to 0, then I would have to go up to what?
6.
Right. Any questions?
Wait, how did you get 0?
I chose it.
Oh, you just chose it.
I just chose it. So let me do this again. Now, I'm not going to use these points. I'm going to come back and show you this again. But the whole concept right now is an equidistant step. So by equidistant step means some people will sit here and say, well, I don't want to mess with this. I want to go straight from 3. I want to go from 3 to 0. If I went from 3 to 0, how big of a step do I have to take here?
3 to 6.
Right. So again, this is a step of 3 and that's a step of 3. All right, so you can choose whatever's best for you guys. Now, with that said, we're normally going to pick ones and make this look like a number line. So I just want to go from 3 to 4 to 5 and 3 to 2 to 1. But I want you to understand the concept of an equidistant step, because if they are equidistant, look at what happens. Those are both 1 step away. Again, I know forward and back, 1 step away from the vertex, right? So let's see what happens to our y values. The only way to do this by making a table is to plug these in. Well, let's plug in 4. When you plug it in, you are only plugging it in for the x value. What is 4 minus 3?
1.
And what's 1 squared?
1.
And 1 minus 1 is
0.
0. Now let's plug in 2 and see what happens. If I plug in 2 right there, what is 2 minus 3?
-1.
And -1 squared is,
1.
and 1 minus 1 is still 0. So if you take an equidistant step, these values will always be the same. Same thing, if I took a step up 2 and down 2, that means these values will be the same. So I only have to plug in 1 value. So let's plug in 5. What is 5 minus 3?
2.
2. And 2 squared is? 2 squared is?
4.
4, and 4 minus 1 is 3. There you go. So this is one way to graph. Now you plot the points. But I want you guys to see this, because you will never see me make a table again. If from here, I took 1 step over, so I'm at 4, now I'm at 0. 1 step over, 0. If I'm at 5, 2 steps over, I go up to 3, 1, 2. 2 steps over, 2 steps over, there you go. So this is what it looks like. And remember, you always have to have at least 5 points in order to graph. This takes some practice, but it's not that difficult. Now I'm going to do the same problem a different way. So I'm not even moving on to number 2 yet. I'm going to do the exact same problem in a different way. My vertex is the point 3, -1. Again, any questions on why my vertex was positive 3, -1? All right. So I still want to draw in that axis of symmetry, and notice I'm putting in a dotted line because it's actually going to help me. Instead of making the table, and my A value here, what's my A value?
1.
Is 1. So the best way to do this is actually to make a little equation. Now, when I say make a little equation, we're talking about horizontal steps, right? So the first thing we did was plug in how many horizontal steps from the vertex we took. So what we're going to do is horizontal steps squared. Then we're going to take that and we're going to multiply that, so times your A value. And that's going to equal my number of vertical steps. Now, you're not even going to have to make the table on most of this, but this is a really good way to explain it. So if I take one horizontal, remember, horizontal is either left or right. It's actually both, left and right. So just like on the table, remember, if I took one step up, I had to take one step back. So let's see this. What if I take one horizontal step? Then I have to square it. Well, what is 1 squared?
1.
Times my A value. My A value is 1. 1 times 1 is just 1. So that means if I take one horizontal step, then I have to take one vertical step, and it's positive 1, so I go up. One horizontal step, one vertical step. Well, what if I take 2 horizontal steps? 2 horizontal steps would be, what's 2 squared?
4.
Times my A value, which again is 1, which means I take 4 vertical steps. So if you watch this, 2 horizontal steps, 1, 2 from the vertex, I take 4 vertical steps, 1, 2, 3, 4. Well, here's where that axis of symmetry comes in play. I took 2 horizontal steps, right? 1, 2, 1, 2, there we go. Just for good measure, what if I took 3 horizontal steps? How many vertical steps would I take?
Nine.
That's it. Because 3 squared, you square your horizontal steps and you multiply by your A value, which is 1. So if I take 3, 1, 2, 3, I go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And again, axis of symmetry. So I took 1, 2, 3, 1, 2, 3. Guys, graphing with the A value with some practice is actually much easier. Any questions? All right. I'm sure there are questions. You're not even sure what to ask yet. So let's do this again. But let's do it number 2. By the way, you don't have to take 1, 2, and 3 steps, and I'm going to switch to light blue here. So again, you always, always, always start by finding your vertex. So on number 2, what is my vertex?
-1, 3.
So that's exactly right. It is -1, +1, 2, 3. That is my vertex. What is my A value?
How is it -1?
Because it's always, always, always the opposite of what's happening to X. Always the opposite of what's happening. Remember, the whole concept here is that would shift it left 1 and up 3. So it's what value of X makes that quantity equal 0. What value of X makes it 0? So if I have X plus 1, well, -1 plus 1 would equal 0, and that's why it's -1. In other words, it's always just going to be the opposite of what you see right here, every single time. Okay?
Got it.
All right, now, what's my A value this time?
-2.
-2. So down here, it's going to be times -2 times -2. By the way, does this open up or does it open down? And how do you know?
It opens
Down.
It has to open down because your A is negative. So again, before I do anything else, I know it's going to look something like this. But again, in math, we don't do something like this. We have to make sure it's exact. So everything else is exactly the same. From your vertex, let's go ahead and draw in our axis of symmetry. How many horizontal, again, left and right, how many horizontal steps do I want to take? Well, how about 1, 2, and 3? By the way, I really don't even need, I don't need that many. I only need 5 points, but I'm just doing this for good measure. So what I do is my number of horizontal steps, that's left or right, I take that number of steps and you can pick any value you want and square it. What is 1 squared?
1.
Times -2 is?
-2.
So if I take 1 step left or right, I go, and this time it's -2, do I go up 2 or down 2?
Down.
And then over 1, there you go. Well, what if I took 2 horizontal steps? If I took 2 horizontal steps, I have to square. What is 2 squared?
4.
4 times -2 is -8. So again, if I take 2 steps left or 2 steps right, I have to go down 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 1, 2, there you go. So we're using everything we know. By the way, this last one is probably not going to fit on the graph. But let's just practice seeing what the value would be. What if I took 3 horizontal steps? 1, 2, 3. How many vertical steps would I take?
-18.
So if I take 1, 2, 3, I'm going to be way down here. And then 1, 2, 3, 1, 2, 3, way down here. So you guys can see, again, it's not a V, but it's a U. And that also says this would be a reflection over the x-axis, or it opens down. It's been stretched, which means it's skinnier or more steep, because that value is bigger than 1. And that's it. So this really starts to get pretty simple if you just remember this formula. Your horizontal steps squared times A, and that's your number of vertical steps. Now, let's do number 3. I'm going to go ahead and erase this. 3 is actually not very challenging. The problem with 3, more than anything, is this. People will mess up that vertex. Oh boy, we did that yesterday. Will somebody tell me what's the vertex there?
0,
I got 0 what?
1.
Perfect. Because you're not adding or subtracting anything to the x. That's the exact same thing as this, but if I'm not adding or subtracting anything to the x, I don't need the parentheses. So it is 0, 1, not 1, 0, not negative 1, 0. That's outside what's happening to the x. Look at the difference from here to here. There's no set of parentheses. So let's go from there. 0, 1. What's my a value here? What's my number, my coefficient for x squared? What's my coefficient for x squared? Anyone?
1.
1. So I've got the point 0, 1. My a value is 1, so this should be real simple. In fact, I can probably just do this in our head real quick. Number of horizontal steps, I'll keep it as 1, 2, and 3. My a value is 1. 1 squared is 1 times 1 equals 1. 2 squared is 4 times 1 equals 4. 3 squared is 9 times 1 equals 9. So if I take 1 horizontal step over, 1 up, boom, boom. Forgot the axis of symmetry. If I took 2 steps, 1, 2, I go up, 1, 2, 3, 4. 1, 2, 1, 2. I took 3 steps, 1, 2, 3, up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 1, 2, 3. And that's it. Any questions? Now, number 4 is kind of a challenge. And notice, I haven't given you guys a whole lot of time to do any of this on your own, and I'm not going to yet. That's kind of what the homework's for. So let me get rid of all this. All right. Let's do this again. What is my vertex on number 4?
Two, -3.
So x is 2, y is -1, 2, 3. Perfect. And what is my a value here?
One and a
1.5.
half.
Good. Does this open up or down? Anybody tell me, does this open up or down?
Up.
Why does it open up?
Up.
It does open up. Why?
There's no negative sign in front of the 1/2.
Exactly. Because your a value is positive, it has to open up. Is this being stretched or shrunk?
Shrunk.
Perfect, which means it's going to be wider. Now, I'm not going to waste time showing you guys kind of what that should look like, but instead, let's do the same thing. The reason I put number 4 up here is because of this. You see how your a value is 1/2, and you see I already went and filled this in, but I didn't fill in my horizontal steps because I do not any longer want to use 1, 2, and 3. Why do you think I don't want to use 1?
Because 1 squared isn't like divisible by, you can't divide in 1/2 and get like a whole number.
Exactly. If you ever have a fraction for your a value, use multiples of the denominator. So I'm going to use 2, 4, and 6. Anytime your a value is a fraction, use multiples of your denominator for your horizontal step. So if I take 2 steps, I have to square it. 2 squared is 4. What is 4 times your a value? What is 4 times 1/2?
Two.
Yeah, it's just 2. So if I take 2 steps over, again, draw in your axis of symmetry. If I take 2 steps, now my vertical steps are positive 2. 1, 2, 1, 2. Horizontal steps, what if I take 4? Well, what is 4 squared? Oh, come on, people. 4 squared is 16, and 16 times 1/2, or half of 16 is 8. So from the vertex, if I go 1, 2, 3, 4, I have to go up 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 1, 2, 3, 4. There we go. Again, I don't think this is going to fit on the table. Maybe it will. If I take 6 horizontal steps, 6 squared is 36. Half of 36 is 18. So if I went 1, 2, 3, 4, 5, 6, I got to go up 18, which is way up here, way up here, so on and so forth. You guys kind of get the point. But it is much wider than what we've seen. And really, that's it. That's how we graph this. All right. Any questions? All right, so make sure you guys get this. It's your number of horizontal steps times A equal the number of vertical steps. You might want to write this down to do your homework. We're going to do these 3 problems and then we are done, but now you'll have some time to do these on your own. So I'm going to give you guys more time than you probably need. I'm going to give you about 5 minutes to try these 3 problems and then we'll go. About 2 more minutes. Again, if you have any questions, let me know. Don't just wait for me to do it.
Were you going to do the fifth equation with the 2x squared?
No, just because we kind of went over that and it's the same thing. So your A value was just going to be 4. All right, let's go ahead and do this. So we've only got about 10 minutes of class, so that was only about 4 minutes, but I feel like I want to make sure you guys are good with this. So what's my vertex on A?
Swan.
My A value is 1, but what's my vertex?
2, 0.
Oh, two. Yeah, sorry.
2, 0. So I start 2, 0, and my A is 1, right? So when you guys do this, make sure you draw in your axis of symmetry. Promise it will help. And because your A is positive 1, it opens up. So let's go ahead and do, so my A value here is 1, so times 1. And you only have to do this twice. How many horizontal steps do you take? Well, let's just do 1 and 2. Equals my number of vertical steps. So 1 squared is 1 times 1 is 1. So if I take 1 horizontal step, 1 vertical step, both ways. If I take 2 horizontal steps, 2 squared is 4 times 1 is 4. So 2, 1, 2, 1, 2, 3, 4. And that's it. So you really only need 5 points. And there's your 5 points. 1, 2, 3, 4, 5. There you go. Any questions about this? It starts to get easier and easier, but it takes practice. Just like hitting a tennis ball, right, Cadence? Or Caden? I said Cadence. I meant Caden. All right, so let's do number 2. What is my vertex on number 2?
-3, 4.
There we go. So here's my axis of symmetry, right through that x coordinate or the h value. My A value this time is what? It's -2. Again, horizontal steps, I can just pick 1 and 2. So what is 1 squared? 1 times -2 is -2. So if I take 1 horizontal step, I go down 2 over 1 over 1. There we go. I take 2 horizontal steps. 2 squared is 4 times -2 is -8. So if I take 1, 2, I go down 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 1, 2. By the way, this is so much faster than making a table. By the way, when we make a table, some people say, I'm better at making a table. That's fine. Make a table. That's okay. But in my experience, there's more order of operations errors making a table than there is doing it this way. Your number of horizontal steps, then square it, times your A value, and that's your number of vertical steps. Questions so far? Then the last one we're doing today will be in blue. So number of horizontal steps times 8. What's my vertex here? Is +1, -2. My A value is 1/3. So how many horizontal steps do you think I should take? I definitely don't want to take one or two. So how many should I take? Anyone?
3 and 6.
Perfect. Multiples of the denominator every single time. 3 squared is 9. 6 squared is 36. 9 times 1/3. 9 times 1 is 9, divided by 3 is just 3. 36 times 1 is 36, divided by 3 is 12. So if I take 3 horizontal steps, I take 3 vertical steps. Again, here's my axis of symmetry. So 1, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3. I take 6 horizontal steps from the vertex. 1, 2, 3, 4, 5, 6. I have to go up 12. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There you go. And that's what it should look like. Any questions? And that is it for today. Tomorrow, guys, try your homework tonight. I know that you're going to have questions, so try your homework tonight. You can do just about all of it. There's still a couple things that we might need to talk about, but that should do it. All right? You can do most of all of it. If you have questions, just don't hit submit yet. We are done. So there's no questions. Go ahead and get out of here. Make sure you guys try your homework tonight. All right? Have a great day, guys.